Alright, hi, welcome back to another exciting chemistry video. What we're going to do today is these molecules that I've showed you how to do the dots for, how to figure out the shapes, determine whether or not the molecule is polar or non-polar. I'm going to show you how to write the names and formulas of these simple molecules. So I want you to start. Can you please write down the I can statement at the top here? I can write the name and formula of a binary covalent compound. Now, another name for a covalent compound is also a molecular compound. They mean the exact same thing. And so when you see this, I want you to think of the word molecule. So binary, in my molecule, we're going to have two different atoms. When you have covalent, that's nonmetals only. And throughout this lesson, besides just learning how to do the names and formulas, I want to compare them to what you learned already about ionic compounds. We spent quite a bit of time doing the names and formulas of ionic compounds. So as I give you these rules and these hints, we're going to take a pause every once in a while, and we're going to put down either S or D, meaning is this rule the same or different than the rule we use to do ionic compounds. Okay. So anytime you see S or D, I'm going to have you determine is it the same or is it different. Okay. So let's start right here. Nonmetals is the fact that molecules are made up of nonmetals. Same or different? Okay. I want you guys to think back and answer it, and we'll talk about it when I see you. And now let's get into it. Let's actually do some names and formulas of some covalent compounds. To me, here's a great example to start. I'm going to show you how to write the name of carbon and oxygen are together here, and I have just one carbon and one oxygen, and compare that to CO2 where I have one carbon and two oxygen. So the first thing to know about these molecules here, carbon and oxygen here, there's one of each. That is our molecule. One carbon and two oxygen, also our molecule. And so what we have to do is we have to indicate how many of these there are in our name. Right? And the way we do that, we are going to use what's called Greek prefixes. Let me bring this closer to you. I want you to write the Greek prefixes for numbers 1 through 10, 1 mono, 2 di, all the way up to 10 deca. These are on page 212 of your honors chemistry textbook. And I do expect you to memorize these. They're not hard. Most of them you should be aware of. Okay. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. Take a moment, write those down. We're going to use these to indicate how many of each atom we have in this molecule. Now I want you to take a moment. Is this the same thing we did with ionic compounds, or is this different than what we did with ionic compounds? See if you can answer that. So now let's take a look at these here. We need a rule for naming our first atom. Okay? Now the rule for naming the first atom in a molecular compound or covalent compound is we're going to use a Greek prefix to indicate how many atoms there are, unless there's only one. I put a big star here. We never start our names out with the word mono or with the prefix mono. So for both our examples here, there's one carbon, okay? The Greek prefix for one is mono, but your first atom you're never going to use mono. So we're just going to write what this element is. Now the rule for naming the second atom in our binary covalent compound is you always use a Greek prefix. No matter how many there are, even if there's only one, we got to start out with one of the Greek prefixes. And then when we're done, we're going to change the ending to IDE. Now, write this down. I also want to take a pause at this point. Changing the ending to IDE for our binary covalent compounds. Is this the same thing we did with ionic compounds, or is this different than what we did with ionic compounds? Write down same or different. So let's use this rule here, finish writing these two for my example. One oxygen, we have to use a Greek prefix. The Greek prefix for one is mono. Oxygen, we change the ending to IDE. I'm not going to write two O's right next to each other. That won't roll off the tongue real well. I'm going to keep it monoxide. CO is carbon monoxide. I love using these two as our example because I know you're familiar, you've heard the term carbon monoxide before. Next one here, there's two oxygens, so instead of mono to start this out, we're going to use the Greek prefix di. And then keep the ending IDE, carbon dioxide, which you've encountered quite a bit. So that's how we write the names. When I give you the names and write the formulas, it tells you how many of each atom there is right in the name of it. Okay? If you don't have a prefix in front of your first word, you know there's only one. Okay? If there were supposed to be two or three or four, there'd be a prefix here, and we'll do some examples with that. It tells you right here, only one oxygen, CO. Two oxygen, CO2. So at this point, I don't have any other rules. Actually, I'm sorry, I'm going to take that back. I do have one rule in a little bit, but we're just going to practice right now. We had a simple molecule. We have sulfur and oxygen in it, so it's a binary covalent molecule or compound. In order to name it, we got to indicate how many sulfurs we have. 2. I have to use a Greek prefix if there's more than one in my first atom. So di, whatever this element name is. sulfur. My next atom here is oxygen. There are 4. The Greek prefix is tetra. And then we're going to change the ending of oxygen to IDE. Disulfur tetraoxide. Now the last rule I'm going to give you about these, notice here I have a 2 and a 4. 2 sulfurs, 4 oxygens. The actual atom has 2 sulfurs, 4 oxygens. You cannot reduce this when doing the formulas. Do not reduce or simplify formulas over covalent compounds, because that actual molecule has 2 sulfur and 4 oxygens. Let's take a pause right here. Let's do our S or D. Not simplifying, is this the same thing that we did for ionic compounds, or is this different than what we had to do for ionic compounds? Look back in your notes if you don't remember. So let's finish up the last minute here. I'm going to give you a few names, and you're going to have to give me the formulas of them. Dihydrogen monoxide. Take a look at the prefixes that I gave you. Come up with the correct formula for this. Do the same thing here for phosphorus pentachloride. So we take a look, we have hydrogen. There are 2 of them based on that prefix there. We have oxygen. There's 1 of them based in our prefix there. Dihydrogen monoxide is a technical term for water H2O. Next one, we have phosphorus. There is no Greek prefix in front of it, so there must be only 1. Pentachloride, which means there are 5 COs. Last one I'll do together with you, and I'm going to have 2 homework problems for you to bring with me tomorrow. Tricarbon hexafluoride. So we have carbon here, a tri in front of it. There are 3 carbons. Fluoride here. There are 6 based on the Greek prefix hexa. C3F6 is your answer. Please do not reduce that to CF2. Okay? It's actually a molecule with 3 carbons and 6 fluorines bonded to it. Alright, so I'm going to give you 2 examples to bring to class. Be prepared to take a quiz. Hint, hint, hint. Number 1, I give you this formula NF3. I want you to write down the name for it. And then I give you the name disulfur tetrabromide. I want you to give me the formula of X. All right. Come if you have any questions. Thank you very much.